graph data. So graphing, remember, is a way to visually represent data. We're going to graph it. Put it on a graph. So, first thing, parts of a graph. There's some parts that you have to include in a graph. The first thing is the title. So the title of the graph should tell us what the graph is about. Should include the two variables. Woo! IV, dV. So it should be like the effect of the IV on the dV, or the relationship between the IV and dV. Effect of the wingspan of the plane on the distance it travels. Now in science, we usually graph the first quadrant, 1, 2, 3, 4. In science, we really only graph this one. Quadrant 1. So we're only looking at this part of the graph. Woo! Just this. So when you graph, you don't, in science, you do not have to graph the other 3 quadrants. We know this is the x-axis is on the horizontal. Woo! And the y is vertical. 0, 0 here is the origin. Since we're looking at this part of the graph, 0, 0 is the origins. And so now we have x and y axes. So axes is the plural form of axis. Okay? So here we have x and y. We have to label them. So the second part is label the axes. Okay, we're going to create the axes and label them. The x-axis always has the independent variable. Okay, it could be time, it could be wingspan, it could be whatever it is. It's just the cause. If you think of it, the cause, even though it's not always a cause and effect relationship, but the independent variable is the thing that you changed in the experiment. It goes here. Dependent variable always goes on the y-axis. So the y, dependent. Y. Y, think of the y-axis. Goes up and down. Y. Dependent. X. X goes on the horizontal axis. X independent. So X is independent. Y dependent. We're going to label what this is. You're going to write down what it is. So for the example I gave with the paper planes, I used wingspan and distance traveled. I'm going to include the units that I measured in. We have the x-axis labeled and the y-axis labeled. Okay, the next thing we have to have is a numerical scale, a number scale. Okay, let's say, for example, I have data that includes the wingspan and the distance traveled for 3 different sets, 3 different planes, the average. I'm going to say the wingspan that had 5 centimeter wingspan, on average it went a distance of 10 meters. Wingspan of 10 centimeters went on average 20 meters. Wingspan of 15 centimeters went on average 30 meters. These are the averages. So now, I want to graph this, let's say. But before I start putting these numbers in the graph, I have to set up the scale, number scale. So, on the x-axis, I have wingspan. So my range is 5 to 15. I'm starting at 0. So my maximum is 15. So I want to set up a number scale on the x-axis where I can include all those numbers. All right, and each index mark, or each space between the numbers should be the same. So let's say I chose an increment of 5 centimeters. That means between here and here is 5 centimeters. Between here and here should be 5 centimeters. Between here and here should be 5 centimeters. Same amount between each one. The y-axis has the distance of the displacement. It goes from 10 to 30. So 30 is my max. In this case, I could do increments of 10. So it doesn't have to be the same increments as the x-axis. On the y-axis now, I have my number scale set up with increments of 10 meters. Look at the data I have and graph that data. So remember, we're using x, y coordinates. Okay, so we go with the first data set. So the data set, we have 3 different data sets here. One data set would be 5 and 10. The 5 goes on the x-axis and the 10 is on the y. So I'm going to go x first, coordinates are x, y. So x, 5, and then I'm going to go up to 10. 1. Remember, we're looking at this, the coordinates are x, y. X1 is 10, 20. So remember, x is on the x-axis, it's horizontal, I go 10, and then I go 20. X1, 15, 30. So it goes 15, 15, and I go up to 30. Where they intersect is where you put the points. I've created my graph. Since it is a straight line, we're going to determine the slope of a line. This is what you do when there's a straight line. We're going to determine the slope. The slope is the rate of change. So the rate these variables are changing. So it's how fast are these variables changing. So how do we get the slope? Slope is rise over run. So rise over run. Rise over run. Rise over run. In other words, it's the change in y over the change in x. Is find 2 points on the line. On the line. Now, they don't have to be points that you actually put, that you plotted. It can be just points on, they have to be on the line. So let's say we pick this point, and I'm going to pick this point. So here we have 2 points on the line. 2 points, one there, one there. Slope. We abbreviate with lowercase m, slope. And it is the change in y over the change in x. So it's rise, because rise, y is vertical, rise. Run, you run horizontally. So that's the x-axis. 1 point on y, x. So here we have a straight line. Okay, I'm going to say this point is x2, y2. This point is x1, y1. Okay, so x1, y1, x2, y2. Okay, figure out what the x2 is, what the y2 is, what the x1 is, what the y1 is. And we're going to put it into this formula. I'm going to just, from this graph, figure out what points up. So where this lines up with the x-axis and where this lines up with the y-axis. That's how we're going to determine this point. So x2 is about, this is about 13. So I'm going to say this is 13. Well, y2 then, it says about 25, 27. So x2 is 13, y2, 27. Now let's go over here. Let's find out what this point is. So I'm going to go down. Let's say this is x is 3, and y is about 8, we're going to say. So x1, 3, y1, 8. Now, I'm just going to take the numbers I have here and put them into the formula. So y2, 27, minus y1, 8. x2 x2 is 13, x2 is 13, x1 is 3. 27 minus 8, 19. 13 minus 3, 10. This then is our slope. In science, we actually convert the fraction to a decimal. Okay, in math, you leave it. Most of the time you leave it as a fraction. Most of the time the slope is left as a fraction. But in science, it's not. So we're going to take 19 divided by 10. We want to take a tenth of 19. That's what we're trying to get. Right? So what do we do with the decimal? Number 19, if just the number 19, if it doesn't have a decimal point in it, it's going to be right after the unit. So 19 is the same as 19.0. 1.9 is the slope. So anytime you divide a number by 10, you have to move. You're moving the decimal over 1 to the left. If you were to multiply by 10, I would be moving the decimal to the right. Okay, so my slope is 1.9. M equals 1.9. So that's the rate at which these variables are changing. The slope is positive. Okay, it's a positive number. You can tell it's going upward. Okay. A negative slope, you would see the line go down. But as we go from here, remember you're always starting at the origin here. So at the origin, this is where you start. When you're reading a graph, this is the origin, is where it starts. So when I say it's going up because we're starting from the origin. If we were starting over here and going this way, it would be going down, but you never start that way. So this line's going up. Positive. There's a positive correlation. In other words, as the wingspan increased, the distance also increased. So in other words, with your planes, the ones that had larger wingspans tended to go further. You can see relationships. This is the purpose of the graph. So this is a positive correlation. As one goes up, the other goes up. As one goes down, the other goes down. A negative correlation, so in this case this would be a negative correlation. And that means if one goes up, the other goes down. It goes up, the other goes down. There's the dance. This is called the negative correlation dance, or the inverse relationship dance right here. It's a new trend. It's called the negative correlation dance, or the inverse relationship dance right here. It's a new trend. Negative correlation. This would be positive correlation. Positive correlation. Or this is positive correlation. Even though they're both going down, they're both going the same direction. So look, this is showing positive correlation here. This graph is positive correlation. That means they both go the same direction. The variables go the same direction. They decrease together. So this is the positive correlation dance. Like this, and you go like this. This, that's positive. So this is a positive correlation dance. This, you go like this. This, that's positive correlation. This, then, negative correlation. As one goes up, the other goes down. So, graphing is awesome. Practice those moves, those graphing moves.